So welcome to advanced feature section of TypeScript, and in case you are wondering if what we saw in earlier section was any less advanced, well, you're right. We did venture into some advanced syntax, but there is no shortage. And if last section felt a bit rushed, that's because it was, as we have a lot of ground to cover. So let's get on with more advanced stuff. Let's start by diving into functions in TypeScript. Functions are a core part of programming, and TypeScript adds an extra layer of power to them by enforcing type safety. This means we can catch potential errors earlier, reducing bugs in our code. Every function in TypeScript has a function signature. The signature tells us what parameters the function expects and what type of value it will return. Defining function signatures helps ensure we use functions correctly and predictably. So let's come up with a simple example to illustrate how function signatures work. For this, I would be using a new file. I would call it advanced.ts.ts and type first, talk later. Right, in this example, the function greet has a signature that indicates it expects a string parameter called name, and it will return a string. This type checking is built in, so if we try to call this function with an argument that's not a string, TypeScript will alert us to the error. Let me show you how TypeScript enforces this type safety. Watch what happens when I pass the wrong type of argument to this function. Right? If I hover, it says argument of type number is not assignable to parameter of type string. Right? But this would go away if I convert it to a string, and now the error is gone. So, as you can see, TypeScript catches the error before the code runs, which helps makes our code safer and more reliable. This feature is one of the reasons TypeScript is so useful. It provides feedback as we write our code. Now let's dive deeper into the parameter types. In TypeScript, we can specify the exact type of each parameter a function accepts. By doing so, we ensure that only the correct type of data can be passed to the function, which minimizes bugs. Just as we define parameter types, we can also specify the return type of a function. This tells TypeScript what type of value the function should return, helping ensure that the function's output is as expected. So let's update our greet function and change its return type, and you will be able to see what happens if we are returning the wrong type. So I'm going to go ahead and change this string, which is the return type of this function, to number. And now you can see a red squiggly appearing under return. Type string is not assignable to type number. Why? Because the function is returning a string here, but its return type is now number. So it's giving us an error immediately. This level of enforcement helps us avoid unintended mistakes. This is a very small example where a function is just one line, but you can imagine in production code where you have function that is considerably large and can have multiple return statements. This type of enforcement would help us avoid unintended return values which the callers aren't expecting. Let's move on to optional and default parameters. These features give us more flexibility when writing functions. An optional parameters allows us to pass a value, but it's not required. To define an optional parameter in TypeScript, we add a question mark after the parameter name. Let's look at an example when we have an optional age parameter in the greet function. So I'm going to fix this return type back to string, and I'm going to introduce age question colon number. Okay, in this example, the age parameter is optional. You can call this function with or without providing an age value. TypeScript will handle both scenarios. Let's give it a try. And you can see the output, hello Alice, you are unknown years old. But if I change this to 30 and call again, hello Alice, you are 30 years old. So as you can see, TypeScript allows us to call this function without passing the age parameter. But your function gracefully handles this by assigning a default value, in this case unknown for the age. Next, look at default parameters. A default parameter is one that has a predefined value if no value is passed when the function is called. This ensures the function always has a value to work with, even if it is not provided by the caller. So let me introduce a change here. So let's say I provide a default value of 50, but to use that, I have to get rid of this optional thing because now it would always have a number. Let's see what happens. So first I'm going to go with this example, which is the same output, but if I remove this and call it again, hello Alice, you are 50 years old, using the default value. Now, this is a dumb example. I know you would never be using this sort of logic to give a predefined age, but you can see the point. This makes our functions more flexible and prevents errors when values are missing. So far we have covered function signatures, parameter types, return types, and how to use optional and default parameters. These features are essential for writing type-safe functions in TypeScript, making it easier to catch errors early and ensuring our functions behave as expected. Now let's move on to function overloading. This is a powerful feature in TypeScript that allows us to define multiple function signatures for the same function, with each signature handling different numbers or types of arguments. So in TypeScript, we can define several different function signatures for the same function and then implement the function to handle each case. Let me show you an example of how function overloading works. But before we get into it, let's look at a regular function. Let's execute it and see the result if it's as expected. And yes, it is. This works fine. The function accepts either a string or a number and handles both cases inside a single implementation. But here's the issue. From the outside, there is no easy way to know what it actually does with each type. This is where function overloading can help. It lets us clearly define multiple expected usages for a function, each with its own input types and return behavior. Now we have defined two overload signatures, one for a string input and one for a number input, followed by a single shared implementation that handles both. A very important point to remember, only one implementation is allowed. All overloads must share the same function body. So what's the point? Well, let me show you how this helps when you are writing code in an editor called VS Code. Let's say you intend to use this format function in an API, which is going to be used by other developers in editors like VS Code. So let me just type first, and then the benefit would be clear. Now, when a developer calls the format function in VS Code, they'll see two separate options with helpful documentation. See here. This is for the first overload, which is giving you the format as string by trimming and capitalizing. And if I press the down button, it gives me documentation for the other overload. You would notice it's not even showing the actual implementation. It just tells you how it handles strings, and the other one tells you what happens when you pass in a number. This makes your code more readable, self-documenting, and easier to work with, especially in larger teams. I hope you were able to grasp the benefits of overloading. Let's now move on to some advanced function features that TypeScript offers. These features allow us to write more concise, flexible, and powerful functions.